Hello everyone, this is Tarun Kaushik and today in this lecture we will be studying about the linear algebra. In the previous classes we have covered complex analysis and the linear programming. In this lecture we will be seeing about the linear algebra. Okay, so I am changing the color of the pen so that it will be easy to recognize what I am making the changes. So the paper 1 consists of 250 marks and paper 2 is also 250 marks, and in the paper 1 5 questions we are required to attempt out of 8 questions, and also in the papers 2 same number of questions. So the complex analysis and linear programming we have covered, and we will be doing the linear algebra. Okay, and you know that we have these two papers are of 250 marks, you already know. So I'm getting many questions, you can say that many mails and messages that which book we can refer, any material for the mathematics as optional. So you can follow these books of mathematics, engineering mathematics. This is of semester 1 book, and the content of this book is this: infinite series, matrices, differential calculus, integral calculus, factor calculus. Okay, so what I have noticed is that in the UPSC mains question, the questions are directly coming from this book. The example of these books are frequently asked in the UPSC mains question, and this book is of the semester 2 book, and this book, the content of this book is vector calculus and the ordinary differential equation, Laplace transform, which we will be doing, and partial differential equation. So this book is very helpful. Engineering mathematics semester 1, 2 and semester 3, these are semester 3. So the content of this is Fourier transform, Fourier series. This is not of our use. The use of our is only this complex variable and the linear programming, which we have already done. The probability is also not asked in the UPSC. Okay, so if you do the practice from these 3 books, then you are able to solve many questions in the UPSC mains, and it is not covering 1 or 2 chapter, it is covering you can say that more than 50-60% of the syllabus of the UPSC mains paper. So from today onwards we will be starting the linear algebra portion, and I think hardly 2 lectures will be more than sufficient for the linear algebra, and in this particular lecture we will be solving maximum of it, and the remaining the portion which I will be doing in the next lecture. You will be came to knowing about that in the later portion of the lecture. So now let's start. So the first question is, you can say that linearly independent and linearly dependent vector. That the question will be asked that show that these vectors are linearly dependent, linearly independent. So how we can calculate, or how we can show that the question is the vector is linearly dependent or independent. Okay, so in the mains 2015 the question for the 10 marks was, these 4 vectors v1, v2, v3 and v4 are given. We have to show whether these are linearly independent or dependent. We have to justify our answer. So the procedure is very simple. Just write down these 4 vectors in the row form, like in this form, and after doing this row operation, I will not you can say that speak out the row operation which I have followed. You just see on the screen. I just follow this operation and made this row this matrix like this. Again I follow the row operation, I made the matrix like this, and after that at last I got the matrix like this. So up to when we are required to calculate the operation, row operation, we are required to do the row operation when we get the matrices in the non-reducible form, because we cannot reduce the matrices very less than this matrices. So after doing that, what you get, the last 2 row of this matrix comes out to be 0, and the first 2 matrices rows of the matrices are non-zero. When the number of the rows which are 0, these are linearly independent, and the rows which are non-zero, these rows will be linearly dependent. So the first 2 rows correspond to the vector v1 and v2 will be linearly dependent. So by mistake I have written like this v1 and v2, these are linearly dependent, so just neglect this in. So these are linearly dependent, and the v3 and v4 are linearly independent, so just put in. linearly independent. Okay, so it's a simple question. The rows which comes out to be 0, these are linearly independent, and the rows which are non-zero, these are dependent. This was for the 10 marks, very simple. Next, reduce the following matrices to the row echelon form and hence find its rank. So the matrix was given this, and we are required to do the reduction of the matrices in the row echelon form, and again also find out its rank. So as you can see, I followed this operation. R2 changes to R2 minus 2 R1, and same like this. So what I get this matrices. Again following the row operation, I got the matrices like this, and again doing the row operation, at last I got the matrices in this form. So as you can see over here, the last two rows of this matrices are 0, which will corresponding to the zero determinant you can say zero determinant of the matrices. When the determinant is 0, then it will not correspond to the rank of the matrices. Okay, so we are required to calculate the number of rows or columns which will correspond to a non-zero determinant. Okay, so last two rows correspond to a zero determinant, so we will neglect this, and the first two rows are, if you find a single component, or you can say single collection of element which forms a non-zero element, or you can say non-zero determinant, then that will correspond to a rank of that matrices. In Hindi, for Hindi speaking, I am saying, यदि किसी भी दो रो के अंदर कोई भी एलिमेंट का कोई भी एक ऐसा कलेक्शन बन रहा है जिससे उसका डिटरमिनेंट 0 बनता है, तो वो जो रो है उस मैट्रिसेस का जो भी रैंक होगी वही उतना नंबर होगा. फॉर एग्जांपल, एज यू कैन सी 2 into -2, और यू कैन से दैट -4, and 3 into 3 -9, and that will comes out to be 10. So 6 minus 4 plus 10 equal to 6. So 6 is a non-zero, and if a 2 cross 2 matrices having a non-zero determinant, then that will be the rank of that matrices. So it's a 2 cross 2 matrices, rank will be 2, because it is not having any zero determinant. Okay, so we have reduced this matrix into the echelon form, and the rank of the matrices is this. Okay, all right, now we will proceed further. Again in 2015 the question was asked, this matrix A is given and we are required to calculate the value of A raised to power 30. That how to calculate? This question can be calculated or solved by using Cayley-Hamilton theorem. What is Cayley-Hamilton theorem? Cayley-Hamilton theorem states that every square matrices satisfy its characteristics equation. Then how to calculate the characteristics equation? Just solve out A minus lambda I equals to 0. After calculating the determinant by this matrices, you will be getting lambda square minus lambda cube minus 1 plus lambda. That will correspond to a characteristics equation. This will be called as characteristics equation of these matrices. Since I already told you that every square matrices satisfy its characteristics equation, that's why replace this lambda by A, so that you can solve out any value, A raised to power 30, A raised to power 100, 200, any value you can solve out. So I have solved this. You will be getting this A raised to power 3 equals to A square plus A minus A. So I just do the multiplication by A both side, so it will become A की power 4, and you will be getting 2 A square minus I. So what you will be getting, you can see series or sequence. You can see here it is 2, and here it is 4, and here it is 2, and here 1 less. Here it is 8, and here it is 4, and here it is 3. So you are getting half of it. 8 का दी हाफ करता हूँ तो what I get 4 से कम 3. Here it is 16 से 16 का half it is 8 is to 1 less than 8 is 7. Again 32 by 2, that is 16, and 1 less than 16 is 15. So there is a sequence. You can say by this sequence you can solve up to A raised to power 64, A raised to power 128, 256, 512. Okay, up to any value you can solve by making this sequence. Since I have to calculate the value of A30, so what I did, I just multiply both sides by A raised to power -2, so that I can get the value of A raised to power 30. Okay, So I get 16i minus 15a raised to power minus 2. So how to calculate the power of a raised to power minus 2? By this equation number 1. So by using the equation number 1, this is the equation number 1. I solve out the a raised to power minus 2 like this, and a30 will become this form. So how to calculate the A inverse in the shortest form? Just write down the original matrices which I have made from the blue color pen. Okay, so 1 0 0 1 0 1 0 1 0. Now repeat the first column like this and the second column like this, and again repeat the first row as it is this and second row as it is this. After doing, neglect the first row and the first column. How to neglect? What will become after neglecting? You will be becoming this. So solve the matrices in the row form in the cross multiplication and write down the answers in the column wise. So what you get? You will be getting the adjoint of the matrices. After getting adjoint, if you divide the adjoint with its determinant, then what you will get? You will be getting its inverse. Okay, after getting a inverse, put the value over here and you will be calculating the value of a raised to power 30. It's a very simple question after that, though it is a very lengthy, but it's a very simple question. Okay, alright. Now next, mains 2015, 12 markers. These 4 vectors are given and we are required to calculate the basis and dimension of this vector space. Okay, so just write down the vectors in the matrices form like in this form and do the row operation which I have mentioned, and after that you will be getting the last matrices in the form. Since this matrices, the last row correspond to a 0 and it will not be the basis of this matrices, and the 3 which are non-zero, this will be the basis. Okay, so basis is the simple things. The non-zero vectors in the echelon form will be correspond to the basis, and the number of bases will be dimension. How many bases? 1, 2 and 3. So the answer will be 3. The dimension is 3 and the basis will be the non-zero vectors after doing the row echelon form, or you can say after doing the row operation, the matrices which will be having its least value, or you can say least element which cannot be further reduced, that will be the basis of the matrices. Okay, in 2014 the question was for the 10 markers. Up to now, have you ever noticed that we have solved many you can say topics we have covered, like in the first we have solved the linearly dependent, linearly independent. In the second we have done the topic of echelon form and how to calculate the rank. In the next we have solved out the Cayley-Hamilton theorem. In the next we have calculated the basis and dimension. Now we are solving the linear equations, the system of linear equation. Then how we can this the equation of matrices, or you can say that equations are given and we are required to calculate the value of lambda and mu for no solution, unique solution and infinite many solution. Then so first of all we must know that how, when a no solution exists, when a unique solution exists, and when a infinite many solution exists. So for that you just remember these 3 things. If the rank of A matrices and rank of B matrices, A augmented B matrices are equal and the number of variables are also equal, then the solution will be a unique solution. If the rank of A is equal to rank of A is to A augmented B but less than the number of variable, then there will be a many solution. और दोनों के रैंक A की और A augmented B की इक्वल ही नहीं है तो उसका कोई भी सोल्यूशन एग्जिस्ट नहीं करेगा. There will be no solution at all. Okay, so what I did, just write down the coefficient matrices, just write down the solution matrices, and A is this, A augmented, this is the B. After doing the row operation, this row operation I have used, this row operation I used, and after that we will be come to this point. When now the point varies here, if lambda equal to 3 and mu equal to 10, both these will become 0. So this will correspond to 2 rank and this will correspond to 2 rank. When the rank is equal to rank 2 is equal to 2 but less than the number of variable are 3. Why 3? Because x, y and z, 3 variables. So when rank are equal but less than the variable, then it will be corresponding to a many solution. And when both these are non equal to 3 and non equal to 10, then what will happen? This will be non-zero, this will be non-zero. Then the rank will be 3 and the rank of A augmented B, that is also 3, and the number of variable, that is also 3. What will happen? There will be a unique solution will be there. Okay, so in the unique solution both are not equal to 3 and more not equal to 10, lambda and mu. And this we have done and this we have done. Okay, so this is very simple question. So eigenvalues and eigenvector, how to calculate eigenvalues and eigenvectors? Very simple. The matrix is given like this, and this question is the example. This is an example. This question is an example of you can say that from that book which I have just mentioned in the full at the very beginning of the lecture. A minus lambda equal to 0, just using the basic characteristic equation formula, making the determinant in this form and calculate the determinant. After doing calculating, what you get, you will be getting here 21. Okay, this is not 19, this is 21 2 1, this is 21 I have written. Okay, so just to the simple calculation, get down this. After solving this, you will be getting the three values, lambda equal to -3, lambda equal to -3 and lambda equal to 5. After getting these three values, you will be solving the vector. How to calculate? These are the eigenvalues, these are values. Okay, these are not the vectors, these are values. But how to proceed for the vectors? Vectors we will be studying in the next example. But before that, we will be taking a look of orthogonal matrices, Hermitian and skew Hermitian, symmetric and skew symmetric. What is orthogonal matrices? A matrix whose transpose, if multiplied with its matrices itself, then the resultant matrix will be identity matrices. This is known as orthogonal matrices. And how to calculate the nullity of a matrices? We have skipped that topic. Nullity. How to calculate the nullity of matrices? It is calculated as number of column minus the rank. For example, rank of a matrix is 2 and column are 3, then the nullity of matrix will be 1. C is column minus the number of rank equals to the nullity of matrix. This is null. N-U-double-L, N-U-double-L, nullity, I-T-Y, nullity. Okay, so in Hermitian matrix, what happens? The Aij equals to Aij conjugate, the complex conjugate of Aij. Complex conjugate means if the sign of the imaginary portion of the number will be get changed. For example, if it is negative, then it will become positive. If it is positive, then it will become negative. Okay, and the skew Hermitian matrices, what will happen? The complex conjugate with a negative sign, then it will become the skew Hermitian matrices. So the eigenvector, we will be solving this eigenvalue we have studied, but in this question we will be solving eigenvector 2. So that as I already mentioned in the previous you can say previous to previous question, we will be solving the eigenvectors in the upcoming slide. So in this you can see that the matrix A is given this, and A minus lambda equal to 0. After doing that, what we get? We get lambda equal to lambda cube minus lambda square equal to this. We get this. After getting this, just calculate the value by trial method, and you will get the lambda equal to -2 plus 3 plus 6. Okay, so eigenvector correspond to -2. How to calculate the eigenvectors? For we are required to calculate the value at lambda equal to -2. So just put the value of lambda over here, here, and here. This is the principal diagonal. What it is? It is called as PD. That is principal diagonal. So just calculate the value of lambda by principal diagonal by putting the value of lambda in the principal diagonal. When you put the in the principal diagonal, what you get? You will be getting the matrices like in this form, and put a column matrices x1, x2 and x3 in this form, and again reduce this by using the row operation. As I used this operation, reduce these matrices into the simplest form, and after doing that, you just put the values of just do the multiplication by this into this. Just do the multiplication. After doing the multiplication, you will be getting the answer equal to this. Okay, and x2 equal to 0 by second row, क्योंकि first element भी नहीं है, third element भी नहीं है. 20 into x2 equal to 0, then x2 equal to 0. When x2 is 0, I put this x2 equal to 0. x2 is to 0 equal, if you put at here, what you get? 3x1 plus 3x3 equal to 0. Then x1 you get minus x3. So what you get? x1 के आगे कुछ भी नहीं है तो 1. यहाँ पे x2 के आगे 0 और x3 के आगे साइन क्या था माइनस का पुट कर दिया. So what you get 1 0 minus 1 correspond to vector. This is the corresponding vector correspond to the eigenvalue lambda equal to -2. Same for the lambda equal to 3 and lambda equal to 6. Okay, so procedure is same. Here you will get this answer and here you will be getting this answer. The procedure is same. If you face any problem or doubt, then you can always put your doubt into the comment box section below. Okay, so that's all for this particular lecture, and I will be doing something, you can say that I haven't go through the detail of that vector space basis. Okay, and we will be doing that into the one more lecture will be required for that, and after that this complete will be this linear algebra will be completed. And this question linear you can say the eigenvalues, eigenvectors, solution of matrices, rank of matrices, these questions are coming in a very frequent manner in the past few years in the UPSC mains. Okay, so your focus should be on the practice portion, because these eigenvalues and eigenvectors requires a practice. If you do not have the practice, then you will be facing the it will be time consuming process to calculate the determinant, like in this form as you can see over here. This portion is a time consuming process. When you will be calculating this, it's a very time consuming process. Okay, so have this practice, and I will be coming back with very soon, and you can say that and after that we will be doing that calculus portion, because once we have done the calculus, then approximate a very large extent of syllabus we will be covering very fast. Okay, so that's all for this lecture, and thank you for watching this. If you really like this video, please click on the like button, and please do not forget to click on the subscribe button. So thank you very much.